Today we're looking at the Louisiana Algebra 1 practice test, and specifically Section 1B. We'll be working through 3 of the items on their practice test using the Desmos graphing calculator, and I'll give you some pointers about things that you can do to work those items. I have created an abbreviated version of a LEAP test, which is what Louisiana calls their state test. And I've just put it in my store this morning. It is 20 questions, but it is really kind of long because some of those questions have multiple parts. One has up to 4 parts. And it'll take a while for your kids to take the test. This test will work with any state that uses Common Core standards or standards that are similar to the Common Core standards. So if you are not in Louisiana and you're looking for a good assessment to give this year for a state test prep or for your final exam, this test would work for that. So I hope that you'll go to my store and check that out. When you get to my store, on the right side, you'll see Algebra 1 LEAP 2025 practice test. If you'll click on that, it'll take you to the test, and you'll see what all is available to this test. I've just got 3 of the pages showing here for the test. Those are actual items in the test. But this long description will take you to the official assessment guide for the Louisiana test. This is the practice test rubrics. So if you'll go to pages 7 through 13, you can see those and the answer key for their test. And this is a link to this channel that you're watching right now. You'll notice there are 54 pages in this document that you're getting. So I know $8 is not super cheap, but trust me, it's a bargain, because if you were to go buy one of these from one of these companies that sell practice tests, you would pay significantly more than that. So hopefully it's something you can use. I didn't make this one free. I may change my mind, but I think I'm going to go ahead and leave it as a priced item so that it's a valid test, because if a whole bunch of people have it, of course the kids will get it too. So anyway. Now, if you go to the Louisiana Quick Start Guide, it's going to give you access to the full practice test online. The one that I'm referring to in this video, and we'll be doing additional videos about it in the future. And the login to this test will be Algebra 1, and the password will be Teach 2025. All one word, lowercase. And then just click on Sign In, and it'll take you into the test. So now here we are in the training site. And then when you click on next, you'll see there are 4 things to choose from here. Now, the first section is no calculator. So I have omitted that from this training, primarily because what I'm going to be showing you is how to use the Desmos graphing calculator to do these items. So I'm going to start in section 1B, which is the second half of the first section that is calculator. Now, when I get in, it's going to give some instructions. These are pretty similar in every section. And then at the bottom, it says begin the test. So we're going to begin the test. And this is the first item we are going to look at. And this one is fairly straightforward. It says to graph this absolute value equation in the coordinate plane, and then it's giving instructions about how to use these features. The point we're going to use to graph the vertex, and then we're going to use raise to graph the 2 lines of the absolute value function. But first, we're going to be using the graphing calculator for assistance. Now, there are 2 calculator buttons available. The one on the left looks like an ordinary calculator. That is your standard scientific calculator. And the one on the right is your graphing tool. It is your Desmos graphing calculator, and specifically the one that we use for the Louisiana state test. So click on the graphing tool to pull up the Desmos graphing calculator. Now, the first thing I want to do is I want to type in this function as exactly as it appears. So I'm going to put the negative, and then the vertical bar, you can actually type on the keyboard itself. It's right above the enter key on the right side of the keyboard. Or you can use this keyboard down at the bottom where it says show keypad. I just like to use the one you type in. Okay, so now I know that the vertex of this graph should be located at 3, 1. So I'm going to move this over here. Unfortunately, I can't resize it, so let's see if I can just kind of move it down. I'm going to press and hold this closed button, and then I'm going to come over here and put it at 3, 1. And I'm just eyeballing the point here. You could change your axis to count by ones if you think your kids will need it. Now I'm going to look for 2 other points on the graph. I've got one at 0, -5. It looks like I have one at 6, so you can drag along here. 6, -5. So let me add that point to my calculator. You can't see what I'm typing. We'll click label that one, 6, -5. So 0, -5, and 6, -5. So I'm going to use the ray tool. So go to this, click on it. We'll begin at our point, and we're going to go through 0, -5, and that's one of our rays. And then we're going to do it again. Starting at our point, we'll go to 6, -5. So it doesn't show the point. That's okay. And now I've got a graph of an absolute value function that looks just like the one in the graphing tool. So that's all we're doing on that first one. The next item we're looking at is item 10. There are 3 parts to this item. You can click through and look at all the parts if you'd like, but you'll notice none of the parts have inequalities associated with this. To make this easier to do all 3 parts, we are going to go ahead and write inequalities to represent. It says Leah would like to earn at least $120 per month, and she babysits for $5 per hour. She works at the ice cream shop for $8 per hour, and she cannot work more than 20 hours. We're told that X is the number of hours she babysits. She babysits for $5 an hour, so let's see what we got here. I'm going to start by clicking on the graphing tool, which is the one on the right, and I'm going to type in X plus Y. Those are her total hours, need to be less than or equal to 20. So let's type a less than and then type an equal immediately, and it will create the less than or equal symbol. And we need 20 hours, so we'll put 20. And you'll notice it's creating the line and the shading for us. Let's go to the next row and we'll create our second inequality. She babysits for $5 an hour, so that's 5x. And she works at an ice cream shop for $8 an hour, so let's add 8y. And the total amount she can earn needs to be at least 120, so we'll do greater than or equal to 120. And so now we have our inequalities graph, but we can't see them very well. Now you can click and drag this down, and this may be sufficient for what we need to do. But I am going to go ahead and adjust my window to be a little bit more like the ones on the paper. You'll notice there are no minor grid lines. There's little grid lines in between. Or actually there are, but we can't do just one, I don't think. So I'm going to just take those off. And my X's on the actual test go from 0 to 25. They are counting by 2.5. But if you put 5, you'll still be able to tell which one it is. So you can just put 2.5. The Y's are actually the same. They're going from 0 to 25 and counting by 2.5. If you do zoom square, that will look more like the actual test. And so let me get out of here. You can close this to get a better view if you want. I think we're good. So now we need to choose the graph that has the shaded part up here in the top left. Let me see if I can pull this over a little bit. It's going to be up in here. So I think I messed this up, didn't I? Let's make this 25. Make this 25. All right, that's going to work. I'm dragging it over just a hair. All right, I've got enough information. I'm looking for this darker shaded region. which is kind of purpley looking on my graph. So let's take a look at our answer choices. It's not going to be answer choices A or B because that would be like this red part, which is not our solution set. We want where the two shaded regions overlap. So let's look a little closer. It looks like one of these crosses at 20 and the other one crosses at 24. This is crossing at 15 and 20. This one's crossing at, that could be 20 and 24. Let's take a look at these two. These points are at 15 and 20. These are at 15 and 20. These aren't. So the only one of these that's like the one in the graphing calculator is D. So the kids would click here to choose answer choice D. Now, unfortunately, when we go to the next screen, we're still on the same question, but all of the work in the graphing calculator that we just did are gone. So generally speaking, you may warn your students in the test, if they've written down an equation or typed in an equation or something, they may want to write it on their scratch paper so that they'll have it to use again here. I'm just going to recreate this graph that I had last time. So I know I had x plus y is less than or equal to 20. Those were my hours. And then I had 5x plus 8y is greater than or equal to, what was that? 120. And instead of doing all that work, I think I'm just going to go ahead and zoom out and drag down, and I'm looking for these points right here. So one way to determine if these points in this list are going to work is just to type them and see where they fall in the graph. So 415, if you'll notice, it's in this shaded region, so I would select that one. The next one is 512. 512 appears to be on this line. Let me make sure about that. No, it's not on that line. Now let me show you why. 5 times 5 plus 8 times 12 is actually 121. So even though it looks like it's on the line, if you zoom in, you'll see that point is just a little bit larger. And it actually does work though, because 121 would put it inside the shaded region. But just so you know, just because it looks like it's on a line, it may not be. So they may need to double check the numbers and make sure it does fit. 5 and 8 will work for 20, or 5 and 12 will work for the 20, and it does also work for the amount. So we're going to choose B. All right, let's do another one. Let's do 10 and 9. So we'll do 10, 9. I can't even see that one, so let's see, where is 10, 9? Well, it would help if I didn't typo it. All right, 10, 9 is also in the shaded region. And then 15, 5. I'm not really taking anything out because I usually like to keep everything in here so I can review it at the end. So 15.5, unfortunately 15.5 is not associated with the blue part of the graph at all. So that would not be an option. And then 19.1, let's see if I can find 19.1. It's the same problem. It's down here in the red. It looks like it's on the red line, but even if it is on the red line, it's not anywhere near the blue, so it would not qualify as a solution. So the correct answers in this problem were A, B, and C. In part C, we're asked to find the minimum number of hours Leah would have to work to earn at least $120. And again, I've created the system of inequalities. I've not spent as much time this time getting it to look perfect, but this should work. I'm looking at the region here. Let me zoom in a little bit. All right, so the first thing I know is she babysits for 7 hours. Well, the X's are 7. So what value of X could I use for my y? So let's try 10. Well, obviously 10 is too small. I can't use 10 because it's not in the shaded region. So let's try 11. And 11 is the smallest value I can use. If I go to 12, it works, but I need the smallest. So I want to be as close to this line as I can get, and so that would be the correct answer. So you would type 11 here. And then the next one's similar. She prefers babysitting. Out of the total hours, what's the maximum number of hours she can babysit? Well, let's see. Let's see what she could start with. Looks to me like her maximum babysitting would be the farthest she can go to the right. So right in here it says 13.3. Well, the directions don't let us use 13.3. So if we do 13, out of the 20 hours, what's the maximum she can babysit? So if she does 13, that would mean 7 hours are left over out of the 20. So 713 would work. Now to double check, you can type in 5 times 13 plus 8 times 7, and you'll see it's 121, so it is greater than 120. So it does qualify as a legitimate solution to the system. So 13 is the largest possible. And you'll notice I didn't really use the equation per se. I didn't solve the system in a traditional manner, but I did use the graph of the system to help me find potential solutions for this scenario. So let's move on to the last question. Okay, the next part is about rewriting functions that are in exponential functions are written in one notation, writing them in another. So if they know their properties of exponents, they may not need the calculator, but it's always a good idea for them to check their work. So we're going to go ahead and type in the expression for part A. The worker had an increase of 2% in her salary for each of 4 years. She plans to continue working for an additional N years, and she's going to earn 2%. Each of those years. So 1.02, I call the multiplier, would be like the base of your exponential function. And since we're doing a function of n, I'm going to go ahead and type f of n equals 1.02, and then I'm going to raise that, which is shift 6, to the 4n power. And so I have this function over here. You can zoom in if you want to see a little bit close in to that. All right, it says it can be used because 1.02 to the 4th power raised to the nth power is equal to 1.02 to the 4n. So what I'm going to do is see if that is true by seeing if these functions mirror each other. And it does appear that this one is on top of that one. So 4n is 4 to the, oh, wait a minute. I guess I should type not the same exact thing. So let's try this again. So we're going to do shift 4, and this is probably not going to work, huh? Shift 6, and then N, and it is the same. See, it didn't matter. So A works. That can be used because of that. So we're going to go ahead and try the second one, and instead of getting rid of that one, I'm just going to turn it off, and I'm going to type in G of N equals, and I'm going to type in 4 plus N Now the first expression is f of n, so I'm doing g of n for this other one because it's got 1.02 to the 4th times, so that's shift and then 8 if you want to use the keyboard, 1.02 to the n. And then hopefully your kids know you would add your exponents. These are not the same. See the difference? 1.02 to the 4th times 1.02 to the n is not the same. So this one is different. So there's no way B is the correct answer because those two expressions are not the same. So let's move on to the next one. I'm going to turn all these off. Let's do another one. The expression 1.02 to the 4 plus n. All right, well, let's do k to the n. Just making up function names here. These names are not important, but for whatever reason, these calculators do not like it when you try to type a function of n with anything other than an x. So I just find it easier to just create function names and go ahead and keep the same variables that they're using. So shift 6 and then use parentheses for your exponent, 1.02 to the 4 plus n. Okay, so there's that. And I want to know if that's the same as 1.02 to the 4th times 1.02 to the n, which is what that says. So that was in part C. I'm going to go ahead and put that here. And so those are both correct. And then finally, I'm going to try the last one. It's not times, it's plus on that one. All right, so let's type the same thing. I'm going to go ahead and copy this, Control C, Control V, and we'll call that J. We're going to change this to a plus. And that is not the same. So it looks like these two match and these two match. So either the answer has to be A or the answer has to be C, because answer B and D are not even true. So let's look at both of those and see which one of those makes sense for this scenario. Okay, it does say that she is going to increase her salary for an additional n years. So that's kind of a clue as to which one makes the most sense. If you have 4 times n would be 4 times, let's say 2 would be 8 more years. But if I want 4 more years, or n more years, I would add more years to my exponent, which is the number of years n. So the correct answer must be the answer C, because that statement is not only true, but it also fits this scenario. So we have come to the end of section 1B, which is the calculator section of the LEAP test. We've only worked 5 parts, but if you'll notice, there's only 3 remaining. So if kids are able to use these strategies using their Desmos graphing calculator, it will assist them in getting more of these items correct. So I strongly recommend sharing these strategies with your students and letting them practice them on these particular items in this online training. I will give you a link in the show notes to this website and the username and password so that you can go in and practice these yourself and with your students so they can get a hang of what this test looks like, what it feels like, and how they could use that Desmos calculator. If you do go ahead and get your own copy of this LEAP practice test, you will get items that are similar to the ones you just saw, and you will be able to use your graphing calculator, your Desmos graphing calculator for kids to do it. These are the items that I've created for section 1 that are similar to the one in the test. And so I was just scrolling through so you can see what they're going to look like. And that's the end of section 1. I've given you an answer key, or an answer document, I should say, for them to write on. But honestly, these are really better digitally. So if you have access to Formative or Edulastic or some other digital way of administering this test, it's really a good way to give it because they can use the same kind of online format and feel. You will actually use the Desmos graphing calculator embedded on Edulastic if you have full premium access to Edulastic. It's a great tool. I used it quite a bit in the classroom with my own kids. But this is what the answer document would look like for this part if you do want to administer it pencil paper. These are the standards that were in section 1B. You'll notice I've skipped section 1A because that was the non-calculator. So this practice test does not have a non-calculator section. You could add the calculator or the non-calculator section that's online for that part if you really want to give all 4 sections of the LEAP test. Hopefully this has been helpful to you. If you have any questions or any suggestions about future assessments, I probably am going to take a break because this one took me a whole week to write. But continue to check my store regularly because I do plan to continue writing items and adding more content to my store over the next year. I've been kind of AWOL for a while because I was teaching and extremely busy and was not able to do all the things that I'd like to do. But I think you'll find this test is helpful, so I'm just kind of scrolling back through it so you can see. And hopefully this video will help you to use this test with your kids. And you can make a difference for them, and they will feel more confident when they get ready to take their state test at the end of their Algebra 1 course. Y'all have a great day.